Hi, my name is Dennis and welcome to the 10th video of C# Fundamental Tutorials. Alright, as you can see, these are points that we've talked about before, but before we proceed, I would advise you, before joining us on the 10th video, please go and watch the videos timelines 1 to 9 before joining this video. We've talked about variables, data types, subroutines, conditional statement, iterational statement collections, and we're still in classes. All right. So what we've covered so far is we've covered the constructor, which you saw in action, and then we've covered property, which you've always been saying before. We actually wanted to work on the structure in the last video, but the time was not enough, so I tend to take the destructor with me to the number 10th video. In order to see, to understand the destructor in a more nutshell, I will explain details. Understanding C# destructor. A destructor is always called once an object is disposed. Okay? As long as your application runs, it tends to collect garbages. So, and these garbage has to be disposed. Your project itself reserves a RAM, it reserves a memory as long as it runs. So it stores all of this garbage is there. So and then when your project or your application tends to close or it's going, this lifespan of your application dies. Most precisely, you have to dispose every garbage that is stored in those reserved memories. Okay, so that you can free the memories of your computer for something else. So garbages are stored in so many ways. In other words, destructor is used to do cleanup. Then use title to designate destructor. A perfect example of a destructor would look like this. You see that small sign there? That is the title. Then use the name of the class. The way you define a constructor, that's how you do it with destructor. The name of the class and close and open and close brackets, and then the curly brackets in between. And then in that block where I wrote console write line cleanup time, is where the tidy up effect takes place. Okay, to see that in action, let's quickly flip up to Visual Studio and write some codes. Now, this is the class that we created in our last video, where we had to create 3 parents constructor. We have 1, 2, and 3. Now, to create the destructor, you use the title, which is here, shift and enter, you have that, and you say parent, close and open, and then curly brackets. That's just it. So this will tidy up the whole entire project. Now, for example, let's assume we are going to store the same object here in a property. Now, this is the best option of showing you how to write a property in a shorthand form, which is prop. And I'm going to save that, call that, give it a type object, and I'm going to say owner, parent owner. So this is the short. You can do it that way or you do it this way. You see, I'm just doing the getter and setter here without involving the variables in there. So it does this automatically. So just take note of that. So now this parent here, I would tend to, first of all, let me go see what I'm calling. I'm calling the third one. I'm going to save the type here, which happens to be the parents that I am going to create. I'm going to create this parent as an object. It's not going to be a class anymore. It's going to be an object. And this, I just want to show you an example of when you close your project, that these stubs are being stored in the memory of the computer and they're still there. Maybe you need to throw them away. So I just want to use this as an example. So this is a parent of an object type. So I'm going to save an object of parent to this parent owner, and then you see it in action when I am throwing, when the project tends, the lifespan of the project comes to an end. Let's see here. What I usually do now, I'm going to throw it away and say null. So I'm flushing it. I'm setting it to be free. So normally it's the same thing saying this is equals to null. So, but let's try it this way. I put a breakpoint here and I put a breakpoint here. I'll run this project, but don't forget in mind we have that already here done. We've declared the parent type, which we've made an object already, and then we have we've done this before. So but this we're going to ignore. We're just here because of the destructor right now. So I'll run this. All right, now we are at the taught a constructor, and now this is an object from a parent, which happens to be this generally, and we are assigning it to this parent owner property that we built here, that we created here. Initially it's null. When I go through it, you see it has something. So I'm going to go out. Now that's been done. I said press any key to close the application. Okay, press enter key, sorry. I'll press enter key. Application is about to close. It jumps into the destructor. Okay, now the application is closing, so it has to flush every garbage that you've been using before. So generally you need this so you can free the memory of your PC, okay, for something else. So if I go here, you see it's there. If I had not put this here that I want to flush it away, the product itself, the application will close, but this garbage will continue to will remain in the memory of the PC. And then, and right there, your memory becomes full. The only time this gets flushed is when you start your PC from new. Okay, maybe you start a computer from new, and that's when you flush this away. So, but why wait till when somebody starts a computer? It could be that it's a server or something, and the server, one can shut the servers one time in a month or one time in 2 weeks. So, but the server memory continues to get full each time you run some packages and you close the application again. So why do that? So why don't you flush away the garbages? So what I do here is I said, okay, this garbage, I don't want you anymore. The application lifespan is over. I'm going to set you to null. Now I'm going to throw it away. Now it's gone. I flushed it away from the system. So the memory is now free. It's allocated. It's free now. And some other products or applications can make use of the memory. So that's it, actually. Pretty simple, nice and clean. Okay. Okay. Let's go see what we have there. Now, as you can see, we've just concluded with constructor, destructor, properties, and now let me quickly. Method is equally included in class groups. That's what I'm going to discuss about them. We've done methods already. I'll show it to you now. It's what we call a subroutine. Let me go show you. It's quite simple. It's here. This is what we did in the past, where we had to create methods. We had to create a method of set a person, which we did here, and then in our past video, and then we created a method with parameter, which we did set person. So if you want to know more about methods that returns dynamic or void and etc., I would advise you to go watch our previous videos so you can see a subroutine, or otherwise known as method, in action. Okay. Okay. Still on classes groups. We've covered constructor, destructor, property, method, and now we are on visibility state. Before we flip into Visual Studios and do some coding, let me just break it short to you. Understanding C# visibility state. Visibility of a class, a method or property tells us how this item can be used. Common types are private and public. These are basically common. You see them almost everywhere, but it doesn't mean you will not meet the other ones like internal, protected, or etc. Now, let me explain you some more types that you may have not seen before. We just talked about public, which we saw there, and we talked about private down here. So, let me read it more. Public member can be reached from anywhere. Okay, you can basically get them from anywhere where you have class being created as an object and called somewhere, and you can reach all those public members. Protected members can only be reached from within the class, the same class, or from a class which inherits from this class. That means the same class that the protected existed in between, is existing in. So, and then internal members can be reached from within the same project only. So that means if it is one project and we have in the namespace, so all the members in that same project that bears the same namespace, they can they tend to find those internal members. Okay, and then we have the private can only be reached by members from the same class. Okay, quite simple. So, but to see that in action, we have to go to Visual Studio and write some codes. So let's go to Visual Studio, and I can demonstrate a little bit of public and private for you, and let's see how it develops. Now, to see most of the things we had here, to see all of that in action, let's talk about the public for now. The public you've been seeing all this while. This is a public type of a property, and this is a public type of an object. Okay, and to demonstrate what I'm trying to explain, I'm going to add a public type of a shorthand string. I'll call this mother. That's a type. So now this is a property, is public. Now meaning I am in the class parent, so it's accessible here. What I mean by accessible, that means I can see it here. I can access it here. I can go here now. There was a place I set the father, mother before. Here, I can say, okay, I want to set the mother here when I view this class. So I can go here and said, okay, this dot mother is equals to is equals to the mother that comes in from that parameter. So, and then if I leave, this is the parent class. So when let me go out of the parent class and go to program class, which is CS, it's another class, and then said, okay, I will assign whatever comes out from mother from the object. I want to assign the mother the mother type, what is stored in mother from the object parent back here into this mother string. So I say, when I say dot, so you see, it shows me here quite clear in the program CS, which is program class. It's telling me that, hello, I am public. You can see me because you define me as public. So I'm seeing mother here, and I'll pick mother, and then I will put my semicolon there. And when I run this, you see that what I stored in mother will come here. Well, definitely I'll get that back from this part of the code, yeah, mother, and I'll assign it here. We've done this before. So I'll run this to the last. Okay, I'll close that again. Now that is the nature of public. Okay, now we should be talking about the nature of protected. Members can only be reached from within the same class, or from a class which inherits from this class. Okay, now a perfect example of this will look in this form. Let me quickly do that. Let me quickly do the first one. The first one will be members can only be reached from within the same class. Okay, let me work on that first. What happens here now is quite clear. So I'll go back and change mother to, what's that again? Mother to protected. See what happens. Okay, and I'll go back to program. You see, I'll take that out. Mother is not, you see, cannot access protected property mother here. So it's not allowed. I can't access it. Okay, so I can't see it because it won't show me because it's not accessible. I'm not giving it out. I don't give it free. It's not out. It's not free for this any other class except its own class and the class that inherits from it. Okay, inheritance we will talk about later. In short, so but it's all about visibility state for now. So, and this will not work, so that's why I can't reach it here. So I can get mother here. So as long as I cannot get mother here, meaning I will not be able to my product, my application will never comply. compile. When I try to build it, it will tell me, sorry, you have an error in parent.mother is inaccessible due to its protection level. So it's been protected. Mother is already protected here, so I cannot reach it. But you know what? In the same class, parents, I can access it. You see, it is here. I can access it, but I can access it outside this class. Okay. The only place, any other place that I can access it is when I have an inherited class. If it inherits, there's a class that inherits from it, that class can access it. Okay. A perfect example of that will look like this, where I have parents, and let me say child. Let me add a class here and say child, and then inherit. So let me just cover that as well. Oh, sorry, public class inherit. Oops, my mistake. Let me get that right. Inherit from parents. Okay, all right. And then when I say constructor CTO, that's my constructor. And look at this. When I say this dot mother is equals to mother. See, I can access it here. So I inherited it. So, but it's accessible here. But the only place I can access it, I can touch it or even use it, is in another class. So that solves the issue of members can only be reached from within the same class or from a class which inherits from this class. All right. Now our next point is internal. Internal means members can be reached from within the same project only. Okay, it's quite simple. This is a project. Okay, if there's another project, that means the mother cannot be accessed in the other project. No matter what, if I join them through to the help of the reference, I will not be able to access that one. But if it exists in this project, the entire project, I can access mother. Let's go try that in action. Let me change here protected to internal. So now you see right here I can access it. It's fine. Let me take that one out. I can access it. It's fine. In the inherited class, I can access it. It's fine. And if I go to program as well, I can access it. It's fine because everything lies in the same complete project. Okay. What I mean project is that. So if I tend to add a new project of a type data dynamic library, for example DLL, let me say project and say library and say library 1, doesn't matter, and I said enter. Okay, I will now say let me do something here and say let me say internal, let me say prop, then string order mother. Okay, now that's public. Now I'll call this class, let me give it a class name, family tree. I'll call it family tree, for example. Change his name, that's the class. So now I'm going to include that library, this C class library project into my, I'm going to reference it here. How to do that is quite simple. I said add reference, and I'll say projects. I'll go to projects, everything that lies in the project. I want that one. I take it. I said okay. Now it's been there. So what I want to do now in my parents, I want to be able to declare, I will declare that class. I will say class library 1. I'll use it first. Just go here and say right here. Okay, let me try to say variable class 1 is equals to new class library 1. Okay, that's the class I'm going to use is what? Oh, sorry, class library 1 dot family tree. Yes, right. Okay, class type on the family tree. That's the family tree. I can just take this one out. I'll be fine. And import the user, which is up there. Then if I say I want to access my mother, other mother, I can say dot other mother. Quite simple. It's working. I can assign mother to it here. I'm so tired today. Now that works brilliant. Now let's go set that to internal. Let's go to the family tree and say, okay, now you are an internal. So it's an internal. It's not a member of that project. It's a member of the other project. So let's go back here and see. You see that it says it's not accessible. So as long as it's not in the same project, this is a project and that is a project. So both projects are different. So as long as it's not in the same project, you can use it. It's not accessible. Okay. All right. Brilliant. Okay. Now let me just comment that out because we don't need it. So we don't get compile errors when we run things. The other one would be the private can only be reached by members from the same class. Okay. Now members from this class can be able to reach the mother. Let me set that to private. Let me set this private. So let's assume this is private, and you look at that right here. I can access it. It's touchable here, but if I go to program, it's not accessible. So I will never get here. So that's the reason why private only works in the same class. Okay, I can get rid of it here. I can touch it here, use it here. Now we've talked about visibility state in our previous video, but not in full details like this. Okay, but I just tend to break it down a little bit more so you get the picture of it. All right, that settles the issue of the visibility. There are other types there, but for now, this is to keep things simple. I just covered the public, protected, internal, and private, and that's that should be okay for you to go. I mean, to lead you in terms of software writing. That will be enough for now. So what do we have? Let me go check again. We just talked about the visibility state, and I showed you a little bit of inheritance. Let me put it half. We will go deeper a little bit because I've done a code and I added the code child and inherited from parents, but we'll dive more of it in our next video. But before we go, let me clean up all this part so we don't get things destroyed. Here is mother. It's not accessible, so I'm going to comment it out. So it's done. And then private here is not accessible. I'll comment that out. So now when I compile, when I try to build, it compiles properly. That means it's fine. Everything is fine. When I run it, product runs, application runs as before, sound and clear. So in our next video, we will be going deeply into inheritance, which I showed you right here. So just get ready for it. All right. See you in the next video.